So here we have g of x, which is a fifth degree polynomial. So we know that there should be 5 zeros. And in order to find the zeros, we want to generate the list of possible rational zeros. This is our list, which we generate from the factors of 2, which are 1 and 2, over the factors of 6, which are 1, 2, 3, and 6. So we divide the numerator by the denominator, and we get 1 over 1 is 1, 2 over 1 is 2, and then we're done with 1. So we now move on to 2. 1 over 2 is 1/2. 1 over 3, oh, I forgot this, 1/3. So we have to include 1/3 in our list. Okay, so let's put that. And then 1 over 6 is 1/6. So now we're done with 2. Now we divide the top by 3. 1 over 3 is 1/3. 2 over 3, we already have it here, 2/3. And 2 over 6 is the same as 1/3. So this is our list. We have 1, 2, 3, 4, 5, 6 to choose from, and times 2 because we want positive and negative in our list. So we write the coefficients of our g of x, which is 6, -7, -19. This is -1, 7, 2. And we'll test which one of these will give us zeros. So we can test if 1 is a 0, and we will find out that it's not going to give us a 0. So we're gonna try now -1. So -1, we bring down 6. 6 times -1 is -6. -7 minus 6 is -13. -13 times -1 is +13. -19 plus 13 is -6. -6 times -1 is +6. This gives us +5. 5 times -1 is -5. 7 minus 5 is 2. 2 times -1 is -2, and this is our first zero. Okay, to find the next zero, we are going to try 2, but it won't work. We try -2, and it's not going to work, so we're going to try 1/2, but 1/2 is not going to work. However, -1/2 will work. So, okay. So let's bring down 6. 6 times -1/2 is -3. -13 minus 3 is -16. -16 times -1/2 is 8. Half of 16 is 8. So -6 plus 8 is 2. 2 times -1/2 is -1. 5 plus -1 is 4. And 4 times -1/2, or half of 4, is 2. And we want to put -2 because half of -4. All right, so now this becomes 0. So we just found our second zero, 1/2, -1/2. So now we can try 1/3, and it's not gonna work. -1/3, we'll try -1/3, and it won't work. So we're pretending we tried it already. And then we're going to try 2/3, and it's going to work. So 2/3 will work. 2/3. Okay. So now we bring this down, 6. So 6 times 2/3. So there's 2 ways to do this. You could go 6 times 2/3. You could put a 1 underneath. We can multiply 6 by 2 first, which gives us 12, and then divide by 3, we get 4. So again, 6 times 2 is 12, divided by 3 is 4. You can also do it this way. 6 divided by 3 first. So divide first and then multiply by the top. So 6 divided by 3 is 2, and then times 2 is 4. We get the same answer. Again, 6 times 2/3 will give us 4. So negative 16 plus 4 gives us negative 12. Negative 12 times 2 is negative 24, divided by 3 is negative 8. Or negative 12 divided by 3, that gives us negative 4 times 2, that's negative 8. I think I like dividing first because it makes the number smaller and easier to deal with. So here we have 2 minus 8. I'm going to get negative 6. So negative 6 divided by 3 is negative 2 times 2 is negative 4. And I'm going to get 0 right here. So now I still have a few things to, a few rational numbers here to try out if it's going to work here. I already have found 1, 2, 3 zeros. I know that I'm looking for 5. Therefore, I need to find the last 2. So if we're looking for the last 2 zeros, it is a good idea to use the quadratic formula. So these are the coefficients of the quadratic factor of g of x. So we can actually write this as 6x squared minus 12x minus 6 equals 0. So we're going to solve this equation. Now, solve this equation, we can use quadratic formula. But I noticed that 6, 12, and 6 can be divided by 2. So I would divide both sides of this equation first by 2. So divide by 2, divide by 2. Remember, whatever we do to the left, we do to the right. So what happens to this? Let me just use this space here for now. So we'll have 6x squared divided by 2 is 3x squared. Negative 12x divided by 2 is negative 6x. And negative 6 divided by 2 is 3. And 0 over 2 is 0. So now my numbers are smaller. This is now my A. 3 is A. This is B. And this is C. So now I can use the quadratic formula. So x is equal to negative of B plus or minus square root of B squared minus 4 times A times C, all over 2 times A. So now let's plug in. B is negative 6. Okay, negative 6. This is negative 6. A is 3. And C is negative 3. Oh, and A is 3. So now we simplify. We get negative of negative 6 is positive 6, plus or minus square root of negative 6 squared is 36, minus 4 times 3 is, okay, minus 4 times 3 is 12. 12 times negative 3 is negative 36. All over 6. Okay, so now x is equal to 6 plus or minus square root of 72. Oh, 72. Or I'll just put here 36 times 2. I think that's even better. 36 times 2, because I have 236. All over 6. Then we simplify. I'm going to go 6 plus or minus. What is the square root of 36? Square root of 36 is 6. And then 2 is not a perfect square, so it stays inside the square root, all over 6. So now we'll have 6 over 6 plus or minus 6 square root of 2 over 2. And then we can divide. So we'll have 6 over 6 is 1 plus or minus. Ooh, this should be 6. Why is this 2? It should be 6. So what happened here? This is 6 over 6. So I just separated the two parts of the numerator. So 6 over 6 plus or minus, and then 6 squared root of 2 over 6. All right, so now we divide. 6 over 6 is 1 plus or minus. 6 divided by 6 is also 1 times square root of 2. So we could just write square root of 2, which means 1 plus 1 times square root of 2. All right, so these are the two remaining zeros. So now we have 1, 2, 3, 4, 5. There's 2 here. 1 plus square root of 2, and the other one is 1 minus square root of 2. So now let's go back to our function. We have g of x. Here we know that the degree is 5, therefore we should be looking for 5 zeros, and we actually found 5 zeros. 3 of the zeros are in our list. They belong to the list of rational zeros that we found. So these are the rational zeros. But these zeros look different. And so we call this zeros that are not rational. Also, when we graph the function, we should be able to see this. And if we put it on decimals, it will give us a decimal value for each of these. So we call these guys irrational zeros. So these are irrational. Irrational because they are not rational. It did not belong to our list. And they are visible in the graph. They're going to be visible in the graph. Okay, so now how many zeros are positive? Okay, right now we have 2/3 is positive, and here 1 plus square root of 2. That will also give us a positive 0. So there are 2 zeros, the zeros that are positive. So let's check the sign changes here. We have here positive to negative, that's one change. Negative to negative, no change. Negative to negative, no change. Negative, and then it becomes positive, that's one change. And positive to positive is no change. So there are 2 sign changes, and we found 2 positive zeros. All right, now these zeros are all visible in the graph, so we call them real numbers. They belong to the set of real numbers. Okay. So now let's put the zeros in the diagram. So, okay. Okay, our first zero is -1. That belongs to the set of rational numbers, and it's a special rational number because it's a whole number. Oh, if it's a whole number, we can classify it as an integer. So we'll put -1 here inside the set of integers. Now, -1/2 is also a rational number, but it's not an integer because it's not a whole number. So that's going to be still inside this box, but it will be outside of the integers. So we're going to put 1/2 here. So we can put the 1/2 outside of the integers, but inside the set of rational numbers. And we can also put 2/3 here. So 2/3. Now, so these are our 3 zeros. Now, where are the 2 other zeros? There's 2 zeros here, and one of them is 1 plus square root of 2, which is another positive 0, and the other one is 1 minus square root of 2. Notice that there are 2 of them, and they're almost exactly the same, except for the plus and the minus. We call these two guys conjugates of each other. So they are conjugates. And if we're getting these irrational zeros from following the quadratic formula, then we'll always have this plus and minus in between these two numbers. And so our final answer will always have the plus and minus. So if that means that if we have an irrational zero, they always come in pairs. They always are conjugates of each other. So if we're going to say that 1 minus square root of 2 is a 0 of g of x, it follows that the conjugate 1 plus square root of 2 is also a 0 of g of x.